Yeah, and then I'll go to the cloud. Perfect.
All right. Yeah, let me get everyone settled down here and then I'll hand it off to you, Marcel. All right. Welcome, everyone. General meeting number 3. Yes, 3. Marcel can't see you guys because this camera is kind of funky. Oh, but oh, there you are. And all right. Well, while I get this fixed, the HDMI broke. Well, no, it's just. There you go. Fantastic. I just won't have the camera face towards them. You'll just have to put up with me, Marcel, and everyone on Zoom.
That works.
But yeah, that's Marcel. I'm just gonna hand it over to him. He's the one presenting today. Marcel, club alumni and advisor. Excellent guy, knows just about everything. Yeah, he denies it, but he knows plenty. Yeah, I'll just hand it over to you, Marcel.
It's all lies. Thanks, Hunter. The truth is I knew none of it freshman year, and starting sophomore year, I got my amateur radio license, and everything I've learned since then. So if you feel like you don't know anything now, that's exactly where I was at. So that's totally fine. Anywho, well, thanks for having me this evening. I know it's kind of a last minute ad, so I'm not there in person. I've got another presentation right after this, so that's on Zoom for a group down in SoCal. So we'll just do this one, and I'll stick around for any questions as long as I can, and then I need to get out of here around 7:20. So tonight we're going to talk about dual band satellite dish slot antenna. So quick intro about myself for those that don't know me. We'll see if I can get my slides moving. There we go. Marcel Stieber, AI6MS. I was licensed in 2008 when I was a student at Cal Poly as KI6QDJ. My roommate at the time, KI6QDF, got his license at the same session, right? So a lot of you have similar call signs. It's always fun. I did my 4+1 at Cal Poly, really 4+1 and a quarter, because I changed majors from mechanical to electrical my sophomore year, largely because I found the amateur radio club. And that kind of changed my interest and moved me towards electrical engineering. These days, my day job is designing consumer electronics, but on the side, I do tower climbing, and I'm technically a ARRL technical specialist, which is just a cool badge. I have it here somewhere. It's a cool badge that they give you that pretty much says, yeah, people can reach out to me for technical help. So that's why I do a lot for the club as well, and other folks. All my stuff's on my QRZ page. I call that the LinkedIn of amateur radio. So if you go to qrz.com, search for my call sign, you'll see all the slides and talks that I have, and links to my YouTube channel as well, where I post most of my talks, or I think all of my talks are up there. So hopefully you'll enjoy that. All right, so today we're going to talk about an improved dual band stealth antenna disguised as a satellite dish. So we'll talk about the background of this, which is actually kind of cool because it's a San Luis Obispo County background. The design of the one that I worked on, kind of what the construction process looked like, and then some testing that I did, which is kind of neat because I think it's really cool to actually share all these little pieces. So first off, why a satellite dish? So oftentimes people live in like HOAs, or they live in restricted housing of some type, that restrictions that don't allow you to put up towers or big vertical antennas or something, or you have to do all sorts of weird permitting to get stuff done. And there's this really neat thing in the FCC that in 1996, they put this FCC CFR 47 section 1.4000, which said you can put up a satellite dish for DirecTV, for like satellite TV, and they can't stop you. So if you notice any homeowners associations, they have to allow you to put up a satellite dish, which is really kind of neat. So this is like a sneaky way that you can get an antenna in and do that. So John Portune, W6NBC, he's actually a local ham down in, I think, Santa Maria or Napoma or something like that, down in South County. He published an article in ARRL QST magazine in 2016. This screenshot from it below, where he did a 2-meter antenna in a satellite dish, which was pretty neat. So I was always intrigued by this. I was always wanting to build one, but a lot of the repeaters I was using were UHF. So I wanted to make sure that I could cover both sets of frequencies. So the 2-meter antenna was not enough for me, and I wanted to figure out a way to make it dual band. So that sets our design goals. So I always like starting with design goals, and we'll refer back to these at the end, because I think it's really helpful to kind of set your goals and criteria when you start out a project. So this one was obviously number one is use an existing satellite dish, right? So I was going to start with kind of the W6NBC design, maintain that outward appearance. You still want it to be able to pass muster, that you could get it in under the FCC exception. And then I set some technical specifications. I wanted better than a 2:1 SWR on both the 2-meter band and the 70-centimeter band. So SWR, for those not familiar, that's standing wave ratio. That's a ratio of the amount of power that you put into the antenna and the amount of power that you get reflected back. So the less power you get reflected back, the lower the SWR number, and that's a better match for your radio. So you're getting more of the energy out. So in this case, a 2:1 is kind of a typical spec that you'll use for mobile antennas, that you want to be under that. 1:1 would be the ideal, where 100% of your power is going out. The two other criteria I had was a single feed line. So I just wanted one piece of coax going to this, because if it was going on your rooftop, or like you had to sneak it into a house, you might actually be able to reuse some existing coax. So I wanted that to be a key criteria. And then preferring an omnidirectional pattern. So not having an antenna with like directivity to it, like a Yagi antenna, or like your TV antennas that are like the log periodic antennas. But I wanted to be omnidirectional. So that means that in any direction, so I set it up on the roof of the house. If the repeater was behind the dish, I would still be able to key it up. Or if the repeater was on the side of the dish, I'd still be able to key it up. That was the intent, right? So you don't have to like go up on your roof and keep pointing it to a different repeater every time you want to talk to a different one, or put it on a rotator. Okay, so when we look at the design, this was calculations that were from John Portune. So he had some of these, and there are a couple other presentations that I link reference in the slide deck as well. They talk about the length of the slot. So I won't go into the details of like the slot too closely, because it gets into like 400 and 500 level EE classes. It is kind of cool though. So if you want to look up more about it, the Antenna Theory website, Jack's really familiar with it. A couple folks are as well. You can learn more about slot antennas. The easiest way that I like to describe it is it's pretty much just an inverse dipole, right? So it's an inverse antenna in this case. So we're really just, if you think of that slot just like you think of like a wire antenna, that's kind of the easiest mental model. The actual physics behind it is weird, because the polarization is actually perpendicular to the slot based on how the electrical and magnetic fields go through it, but we digress. So, so the slot length, if you think of it like a resonating antenna, you're calculating it using some factors here. So we use the formulas that they provided, which gave us this baseline of like about 38.5 inches for the VHF and about 13 inches for the UHF. So that's pretty long. And if you kind of see the sketch on the bottom right, that gives you an idea. The red being that VHF slot, that's about 38 inches. That's kind of the size that you need to make it work on the dish. You can't make one straight line and 38 inches wide, because the dish isn't big enough for that, right? So you have to kind of fold it over. And that's one of the things that we start finding is a compromise, right? So anytime you make compromises to antenna, it makes it less ideal, it makes it less perfect, but often it still works, right? And that's kind of the cool thing. You can take a wire antenna and take it around the edge of your house and make it like into a square, and it'll still work. It'll just have a different radiating pattern, different performance characteristics. The second thing that we need to calculate is the actual feed point. So this is where the coax connects to it. And that's from one end. So from one end of the slot here, can you see my mouse? I don't know if you can see my mouse. Yeah, okay, thanks. From one end of the slot here, like you'd have to go 1.26 inches out, and that's where you'd connect the feed point. And I'll show you what that looks like up close, because it's kind of a brain twist as well for how that works out. So knowing these are the kind of the baseline calculations, I'm not going to go into all the details of where the calculations came from. That's in some of the other references and papers, but we could use that to then figure out how we want to fit on here. So I was kind of playing around with, okay, well, how can I fit these both onto here? Like, how are these going to interact with each other? I want to be able to hook them together and use a diplexer. I'll talk about that in a moment. But trying to figure out how to fit these two slots on here, I was kind of playing these with blue tape, these two different options kind of how to fit it on there. Things we considered, like the placement of the slot and the interactions between the slots. We didn't know how much the two slots would interact with each other, because you have to kind of imagine there are these electrical currents going around the slot. So if you just look at this upper blue slot, there's electrical current going around it as when you feed it. So, because there's a slot in the middle and that slot doesn't carry any electrical current, right? It carries the magnetic field. So, and then similarly for this larger slot, you have current going all the way around. So when I looked at this right design, I originally didn't want to do this because I was worried that that other slot being in kind of that current path that's going around the big slot would cause issues, right? So this was kind of gut checks. I wasn't actually modeling or simulating this. So I kind of just said, okay, we'll try it out. We'll get more on that later. The other point here was a diplexer. So a diplexer, for those that aren't familiar, is something you can use to combine like 2 radios into 1 antenna, or 1 radio out to 2 antennas across different bands. So a duplexer, you might have heard, that's what we use for like repeaters. That's usually within a band that you can transmit and receive at the same time on really similar frequencies. A diplexer is to be able to do that on different frequencies or different bands. So in this case, I wanted to use a diplexer to combine the 2 antennas into 1 cable, and I'll show you what that looks like a little bit later. But that's how we meet our single coax feed requirement. You could also feed it with 2 separate pieces of coax, but by adding the diplexer, it meant that I only needed 1 cable. So that was pretty useful. So step 1, get a dish. I don't know if there's still a couple sitting in the courtyard in case someone wants to try this out. Otherwise, you can usually find them free pretty quickly. So Craigslist, a quick search, or just poke around or ask on some mailing lists, or walk around some houses and look for a dish that's not pointed at a geostationary satellite. It's pretty easy to do because geostationary from where you're located is only in one direction. So if the dishes are pointed in another direction, they're not being used, guarantee it, unless it has a slot in it and they happen to be a ham radio person, in which case you want to say hi to them anyway. Yeah, so look around for them, find them if you wanted to try this out. If you have the same requirement that I did to only have 1 feed line, then you'd need a duplexer, or sorry, a diplexer. So you could buy one new, 35 to 70 bucks if you go buy them off of Ham Radio Outlet or DX Engineering. You can get them used. You can build one by hand with just a couple of passive components. It's just an LC circuit, so inductors and capacitors. It's actually pretty easy to do, especially if you're not putting a lot of power to it. Or you can get super lucky, like my buddy and I did at an electronics flea market, where we found a box of these for $1 each. I'm kicking myself for not buying more of them at the time because they're actually really good. But that was kind of funny. The only thing I warn is make sure you check the frequency split. So not all diplexers are made the same. They're for different frequencies, different bands. Even the terms VHF and UHF, when you look at their international standard definitions, they're very different than the way ham radio operators use them, right? So just double check the frequencies, match what you're expecting. So in this case, this one just barely worked, 144 to 174. It actually does work lower than that, but it's not rated for it. So it's just something to keep in mind. Cool. Then we measure, mark, and cut, and measure again. Sorry, I forgot the second measurement. Don't want to mess up these cuts because they were actually pretty difficult. This steel is surprisingly rough to get through. I did a combination of cutoff wheels and what did I use? A reciprocating saw or sawzall, I think, and that's why it's not a very straight line. So not my finest work, but it doesn't really matter because the RF doesn't really care that much. So marking it out carefully, making sure the dimensions are correct, and then going from there. The first thing, when you see this big cut that we put in here, if you just put a straight line cut, it actually maintains most of the integrity of the dish. Once you put this 2 right angle cuts for the big bent VHF slot, the whole thing gets really floppy, like almost instantly. The whole thing just fell apart. So one of the key things is having a non-conductive support brace to maintain some integrity of the dish at that point. So in this case, this was just temporary. I just put a wooden block that just held in place to make sure that it didn't bounce around too much. I also mounted the diplexer on the back here, so kind of just tucking it away in the corner so it's not super visible. And then you can see I already drilled the holes here for the feed point. So the feed points are just little holes where you then hook up the actual coax. So this is the part that's a little bit of a mind twist, right? Antennas are kind of magical in some ways. You literally just hook up the ground to one side of the slot and the center conductor to the other side of the slot. And when you excite that location, right, that's the feed point, it causes this whole slot to radiate, right? So that's what's kind of like magical about it, if you think it, because really electrically these are shorted, right? So electrically there's a connection right around the edge of the slot here, where if you measure a DC voltage across these, it's 0, right? A DC resistance, it's going to be 0 effectively. So that's what's kind of fascinating. We do put these chokes in here. So these were just, so they're called 1-to-1 balance in this case. It's just effectively a handful of circles twisted in, and then you connect them tightly together. That helps remove some of the common mode energy that comes down the cable just from any mismatch. And then these both go into the diplexer here. You'll notice I sealed that nicely. So that's the coax seal that you're probably familiar with from around the shack as well. And yeah, connect that all together. And then we have our single feed point. So initial tests, throw it up on my bicycle repair stand in the backyard of my rental at the time. And the frequency was too high, but that's a good thing because you actually want it to be too high because you can cut the slots longer. If you make it too low, it's annoying because then you have to like fill in the slot. You can do it with like copper tape or something, but it doesn't look as clean. So I intentionally cut a little bit under just to make sure I could tune this in, right? So these plots are from my little Rig Expert antenna analyzer, AA600, similar to the one the Shack has as well. So all we had to do is cut them a little longer. So you can see I marked here from the pencil out, and then pencil out, I did it kind of symmetrically on the VHF, and then brought them bang on right into kind of that center frequency. So 146.9 and 445, kind of pretty flat there as well. And both of these are well under SWR of 2. This one sneaks a little bit over, but that's outside of the frequencies that we cared about. So final lengths are here in case anyone wants to try to mimic those exactly for where the feed points were and what the actual slot measurements were. And you notice how the feed point shifted a little bit when we did the VHF because we extended the slot on both ends. So I could have extended just on one end. I wanted to keep it symmetrical just because, so that moved the feed point a little bit. So final product with a little bit of gray spray paint looks like this. The DirecTV on this dish, the logo on the dish itself was pretty much gone already, so it didn't really work out too well. But it had a nice mount on it, and I just had it on this big wooden frame. So pretty cool. From an SWR perspective, that's fine. But we know that SWR is not everything. That just means how well is it matched, right? A 50 ohm resistor has an SWR of 1:1 as well. It's a perfect match because it absorbs all of the energy on a 50 ohm line, but it doesn't radiate very well. So it's not a good antenna. So how do we check if it's a good antenna? Well, we have to do some over-the-air tests. So this is my hacked RF chamber. It was just a park in Sunnyvale, and my lovely wife and I went out to the park for a day, and on this little hill, we set up the antenna with a little signal generator. So the AA600 actually can generate a signal, which is kind of cool. And then she sat at the other end with a directional antenna and a spectrum analyzer and measured the received signal strength. So this is a transmitted test, effectively a kind of TRP measurement, total radiated power, where we're sending that signal out and then we're measuring it at the receive side. So as long as the source is steady and always the same level, then as we turn the antenna in different directions, we can see how much the signal fades off in various different directions and know how omnidirectional the antenna is, because that was one of my design criteria, right? So key thing is document. So it's really good to like write these details. I literally took these notes, 2 years ago now, and very specifically writing down exactly what we're doing meant that I can double check my work. I can double check exactly what measurements I took and how I did them. Even the antenna orientation down below, we defined what 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock positions were as we did our rotation. I could have done this with degrees, but this was easier for me as I was mentally rotating. And then we were talking back and forth to make sure we were writing it down correctly. So this is what that testing looked like. Just we set it on a milk crate and then just slowly rotated it. This is my tape measure Yagi antenna. You recognize that from the transmitter hunts that I used at the receive. And then just effectively a protractor, but I used just a carpenter's square and a and a cheap bubble level to adjust the elevation. So by going through and documenting all these measurements, we went through and did both VHF and UHF measurements. So we did 1 round at VHF, 1 round at UHF. And then I also did a baseline against a known antenna with a known gain. So this was trying to figure out like what the antenna's gain actually was. Didn't work out as well as I hoped because for a number of reasons, but we were trying to figure out like if I had a known antenna that has a spec on it, I can use it to calibrate the setup effectively. So we did that as well and just marked the different different angles and all of those things and front and back. So by putting this all together, you can see it's all the orientations and then the different angles. We then plot them, and this took quite a bit to actually plot them, but you can see the radiation pattern. So this is kind of cool. So for those not familiar, so this is an azimuth. So this is like if you're looking straight down from the sky onto the antenna mounted horizontally. So the dish is sitting vertical, I guess, but the antenna is effectively in its normal orientation. We have actually the strongest signal to the back. So this is kind of interesting. So it actually, our 0 dB, which is what we say is like the nominal for this antenna, is straight to the back, right? And then to the front, we're down about 2.5 dB. So that kind of gives you an idea of the difference of the power from front to back. So that's what's known as a front to back ratio. And that's at VHF. Right now to the sides in the worst spot here, we're down at about 9 dB down or 8 dB down. So that's how much worse the antenna is in those directions. So it's definitely not a perfect omnidirectional antenna by any means, but it's not bad, right? It's not terrible. Even a 9 dB down, that's only, you know, a couple S units on your radio. So if you're talking to repeaters locally, it'll probably still be fine. At UHF, it's a little bit worse, right? So front to back is actually a 0 because they were both 0 at perfectly forward and perfectly backwards. But we have some pretty big nulls here on either side. So that's probably due to how the slot sits on the dish and it's not folded over at the ends. We actually are almost 20 dB down or more than 20 dB down. Sorry, 15 dB down. I can't do my math here. Down on the ends, right? So what that means is if I'm setting this up on my roof and I know there's a UHF repeater that I want to talk to, I'm going to make sure that it's not broadside, right? It's not sticking out the sides of the dish. So I'll rotate the dish a little bit to make sure I'm not in that null. Otherwise, I'm losing quite a bit of power, right? So that's azimuth. And then we do elevation, which is kind of the same thing, except on kind of the cross section, right? So I put the dish here in the background so you can see what that looks like. Pretty similar patterns. The interesting thing here, the UHF, is it's much stronger down, which you think is a little counterintuitive because you're like, well, but Marcel, there's this big feed horn arm here that you're not using, right? That's the old satellite feed horn for the actual satellite dish, which you could still use, by the way, if you wanted to still use this for direct TV. You just have to point it at the satellites correctly. But this one actually has a stronger signal down on UHF. The VHF, its strongest signal is actually up, right? So up here, like pointed up to the sky. So it's kind of interesting. But again, this has, you know, on the UHF, most of it in the horizontal axis is pretty good. Like you're plus or minus 2 or 3 dB or 4 dB. That's pretty good. And on VHF as well. But if I were to install this, I'd probably, you know, you might, depending on if you're using UHF or VHF more, you might tip it down a little bit or you might tip it up a little bit to get better signal. But you can always try it and play it around. The neat thing was after I built this, John Portune was nice enough to simulate what we built in EasyNIC, which is a cool little simulation software. It's actually free now. The person made it free available online. And he simulated the exact dish that I built. Obviously, a couple assumptions that you have to make and kind of pull it all together. But it's this kidney bean shape, and it was really, really cool because when I did that same, overlaid it with the blue plots that I got, and then I added the extrapolated data to kind of mirror it. It's almost the same. Like I was pretty proud of this, right? So like the actual measurement that shows simulation actually matched what we measured more or less. Note that it's normalized, so the actual amplitude here won't line up because we didn't calibrate the two measurements against each other. But that was pretty sweet. So it's always nice when a plan comes together. So lessons learned. The big one was centering the slots. So this is the one that if we go back, like when we go back to this vertical slot, right? So because the UHF slot was so high on the dish, and that's actually why I put this higher in the plot, it radiates down because there's a better, presumably because there's a better ground plane down below that it's actually like pulling the signal in that direction, right? So one of the things I would do is I should have gone with that other design where I actually put the UHF slot inside the VHF kind of C shape or whatever N shape. So the other thing is the proximity of the two slots doesn't seem to have much impact. So John tried a couple different simulations where he like moved them closer to each other, further apart, and played around with that. It really didn't seem to impact either very much. So that's a pretty good data point. That means that if you do build one of these, you can put the slots much closer together. So that's pretty cool. And then the last one is something that I'd want to try out in the future is see if I could eliminate the diplexer by getting a little bit smarter with how we do the coax feed. So you could either do something with a single piece of coax, like these two kind of sketch drawings here, where you just have a single feed point that's energizing both slots at the same time. I haven't tried this out, but it would be kind of neat to test out. Or you could do a Y coax. And what you do there is you'd actually use the length of the coax as filter stubs effectively on the other band. So you'd feed one versus the other with the right wavelength of the opposite frequency so that it would block out those signals. Be happy to explain that to someone if someone wants to try it out, because I think that'd be kind of neat to do. We could technically do it with the one I have, except I gave it away to someone that's using it at a summer camp for kids. So I don't have mine anymore. So yeah, just to wrap it up, looking at the design goals, I always like to go back to those original goals. So check, we did the existing satellite dish. We maintained the outward appearance. We had well, pretty much, we have some of these cables in the back, but we painted it all gray and it pretty much disappears. I didn't paint the diplexer because it was a pretty label and I didn't want to mess it up. The SWR we met actually exceeded that criteria. The 2 meter is a little bit broader than that, and same with the 70 centimeter. We got a single feed line and relatively omnidirectional. Again, the UHF wasn't as good, so that one was pretty far down on the ends, kind of broadside, but that's something we can work around if we know that now. So big thanks to John Portune, W6NBC. The fun fact is he actually administered my amateur radio technician license back in 2008, so that was pretty cool. But he helped out a ton with this. He's really open for me chatting with him and just brainstorming. One of these days we might write this into an article for QST. But yeah, he did a really great job with that and was super fun. So with that, I will open it wide open for Q&A, Hunter, and anything that anyone in the room has.
Awesome. Well, thank you for the presentation, Marcel. Yeah.
Thanks.
Very good and informative presentation, you know, the whole process. Does anyone? Oh, Jack has a question.
Jack, of course, has questions. Go ahead, Jack.
Go ahead.
Yeah, thanks for the. Oh, Mike was in a different place. Thanks for the presentation. Did you ever experiment with painting the dish, for example? Like if the dish had a big, corporate logo on the public-facing side, right, that we can see here in the photo, and you wanted to get rid of that without messing up the metal too much? I mean, have you looked at like any kind of paint, like something that non-RF interfering? Have you? What do you have about that?
Yeah, no, it's a good question, Jack. So two things here. So one is like, as long as your feed point is nice and conductive to the actual metal itself, in theory, the surface coating shouldn't have much of a difference, right? There will be some, but it's not actually carrying the energy. Now, if you made it with a conductive spray, so if you used like a metallic spray, it might actually try to conduct some of the energy, and then you might have more losses potentially. But generally, the paint surface doesn't seem to have much an impact. The thing that does have a very big impact, and this is one of the slide, we'll show the slide link here, but there are a couple links here. This N5CEY did a really interesting presentation on his. He actually tried filling in his slots with epoxy and then painting over it to make it really look really clean. And that was a big problem. It didn't work out well for him at all. He had really lossy and it really changed the performance characteristics. Presumably because it impacted the velocity factor in the slot, right? Because open air has a very different velocity factor than putting in like epoxy or something. So that's the big one to watch out for. I haven't played around with like different materials for the support structure here. The slot width is something that people have considered playing with as well. In theory, a wider slot should increase your bandwidth. For the bands I was dealing with, I found it to be good enough with just whatever blade I had, that width was sufficient. But it is something to consider, especially if you want to run more power into this too. But it's not exactly a high gain antenna, so you have to be a little careful. Then to your question, Jack, or do you have any follow-ups?
Yeah, thank you.
Yeah. But yeah, so if you wanted to like paint the C-Park logo all over it, yeah, go for it, right? It'd be great. Now, part of it is like a lot of the other designs I've seen, they try to retain like the DirecTV logo that's on there to make it look less suspicious.
Oh,
right?
I see.
So they actually intentionally keep the old logo on there to make it more hidden. Like this one, I just painted a matte gray and didn't really care too much. It was just kind of a fun project. I didn't actually end up installing this. I just threw it on the roof of the garage for a little bit with the little wooden H frame and then gave it away pretty quickly because I didn't need it, but it was a fun project. Other questions?
Any questions, Ryan?
Would it be possible to do essentially a log mag with a bunch of slots to get a like broadband receive, or would you just want to make wider slots or more slots for the band you're interested in? Or
Yeah, it's a good question. I don't know the answer to it straight away. My initial gut reaction would be, I mean, yeah, you could in theory scale up what I did with a bunch of diplexers in each of the bands you want to cover with another slot, though that's kind of messy and gets pretty pretty messy pretty quick. If you did, because we didn't see a lot of interaction between the slots, I think you'd have to design your slot to be multi-band. So that was actually, I didn't mention that in this talk, but one of the other things I was wondering is there a way you can actually cut these slots to be multi-band? So if you think about like cell phone antennas, like dual band Wi-Fi antennas, they have like an F slot antenna, right? There are different ways that you can do antenna design to actually make it radiate at multiple frequencies. You could definitely go that route. It's very common in like cell phones and tablets and stuff, and you just scale it up to the frequencies that you care about. Making it properly broadband in this setup, I think would probably be more difficult while maintaining the outward appearance, because you're going to have either a ton of cuts or they're going to be really wide or have a weird shape to them or have a lot more open space to cover. Like if you did like, what are they called? I forget, it's like one of the like funnel shaped antennas effectively. It's
The
just gonna take
Vivaldi
away-
ones.
A Vivaldi, that's the one. Thank you. Yeah. So if you did like a Vivaldi antenna on this, I think it wouldn't look like a dish anymore. So
Yeah, it would not.
Yeah.
That would be interesting though, to experiment with like a tree, like a fractal tree structure cut.
Yeah, absolutely. Yeah, that's one idea. And the other thing is, satellite dish is just one option for something you can start with, right? A lot of the like stealth antenna design is really big in industry, especially in the cell phone industry these days, because they're trying to build like trees and palm trees that have cell phones antennas in them. If you can build those antennas into the structure that actually looks like the natural structure, like for example, having a tree stump or like a big tree that has slots cut into the side of it and are radiating slots, and it just blends into the bark texture you have on it, then you can hide an antenna into something like that as well. And that's really interesting. Like their whole companies devoted to making hidden cell phone antennas. So there's definitely a market for that if you want to do a startup company. You heard it here, folks, first. You heard it here first, folks. Wow. Yeah. Okay. Other questions? Nothing? Show of hands who actually wants to try this out. Hunter, how many hands are up?
Well, Ryan, maybe Kevin.
I have a question.
Oh, Kevin has a question actually.
Yeah.
Oh, good.
So like in theory, you can, if you don't care about the stealth part of the stealth antenna, you just want to build a slot antenna. You can like CNC any shape into a metal plate and it would just become an antenna.
Pretty much. Yeah. So people have built these out of cookie sheets. You can build this into like the roof of your car if you want to cut a slot in the roof of your car. You can take the old barbecue lid that we throw away and like put it in that. Like pretty much any piece of metal that you want to put a slot into, you could do that. Side of a shipping container, right? Literally tons of options. So yeah, the cookie sheet option is actually a really neat one. Often when people want to experiment, so a couple of the articles I read from other people experimenting with slot antennas, they'll do even just a sheet of aluminum foil, get like really thick, heavy duty aluminum foil mounted on a piece of cardboard, and you can cut out different slots in it and try out different things. And just use copper tape to patch it effectively. So you can extend and change the lengths or cut out a different slot and just play around with it. Or you can simulate it, right? So it's, whatever you're more comfortable with. Some people like to do it practically. Some people like to sit down and try to simulate different slot ideas. Yeah, if I were to do this again, I would probably sit down and do some more experiments at that level. Because once you're cutting into this material, it's a one-way door. You don't want to like go back and change it because it's pretty painful to work with.
Nice.
Other questions?
Any other questions?
I'm not super familiar with how dishes help transmit radio signals, but when cutting holes into something like a cookie dish or a barbecue lid change the signal?
Yeah, no, good question. Like a cookie dish, again, it comes down to the size of the slot. So if you're just putting a little UHF slot into a dish that's this, like into a sheet that's like size of your oven, right? That would actually work really well. It'd probably be better than this antenna that I built because you have a nice like uniform space around it and it's flat. So your nulls on the edge would probably be less. Now, if you tried putting a 2 meter slot into a small cookie dish, and you're doing like a big loop-de-doop around, it's probably not going to be as good because you're not going to have as much ground plane around it. So like the ideal slot antenna is an infinite ground plane that you just cut the one little slot into, right? That'd be the ideal. Anything besides that would be a compromise. So yeah, like the barbecue lid example, if that's like a full half circle, like a hemisphere, yeah, that one would definitely have some weird radiating patterns, right? You could probably make it a match still. You could still get it to work and connect to your radio and have a good SWR, but it's definitely going to change the antenna pattern. So it'd be pretty goofy. The one other thing to add kind of on that note is looking at this dish itself. In theory, there's nothing stopping you from still using this dish as a DirecTV dish. So the key things there for like the dish antenna, this is a reflective, right? It's a reflector. The actual antenna is here as a little feed horn that actually has a little LNB in it, so a little low noise amplifier that's receiving the signals, and then the cable runs through this rod and pops out. I disconnected it on this one, but as long as the shape of the dish is still held intact, these slots would have a pretty minimal impact to the received signal. So you could still use this for satellite TV reception. So even if someone were to discover, hey, that doesn't look like a normal satellite TV dish, well, it is actually one, and it still works as one, and I have it hooked up as one. So you can't tell me to take it down. So that's kind of the neat thing about it. Now, it will force you to point it in a certain direction if they're really being pedantic about it, but generally speaking, you'd be fine.
Brian has another question.
So if you were using it to receive, would transmitting that much power damage possible cable receivers? I know it's like at a way different frequency. Could it damage the LNB if it's getting bias T power or whatever?
That's a good question. It'd be separate feed lines, right? In this case, so we were running separate feed lines. So you'd be talking about over the air, so that like this slot would be radiating and the energy would be coupling into this. Yeah, if there's electronics in here, and a lot of times it's just a plastic housing, it's not actually shielded well, that could be a problem. That is a good point. So transmitting, I mean, try it out, hook it up and listen to a satellite dish and use a cheap satellite receiver you don't care about.
Exactly. My guess is it probably wouldn't damage the LNB, but it might desense it or something. It's probably far enough away, but maybe not.
Yeah, you're definitely in the near field for the antenna, right? So you're definitely getting some higher power levels. Like it's 1 over r squared, right? Is the power drop off from the distance of the antenna. So you're very close. So yeah, if you're running 50 watts transmit or 100 watts transmit, for example, yeah, I could see it causing problems at that distance. The other thing that I would be worried about too is just energy getting into that other piece of coax, even if it's not damaging the LNB or anything, but energy getting into the coax, going down the coax into the actual satellite receiver box. That receiver box is probably not designed to have like all that energy coming down the cable, potentially down the shield of the cable as well. So you might need to add chokes or something onto that as well to protect the electronics downstream. So those would be the things I would think about.
Yeah, probably a choke and a band stop filter for on the ham bands, because I'm assuming the LNB blocks it down to around 1 gigahertz or so. So
yeah, it doesn't do very much below that anyway. So
yeah, so
yeah, worth looking up. You could probably take it apart too and see like what that design is and potentially modify it or something too.
Yeah, that'd be interesting. It would be cool. I know we don't have access to QO100, but for people living in the other hemisphere, it would be cool to have a 2 meter 70 centimeter slot antenna and that also works on 5 and 10 gigahertz for QO100.
Yeah, that'd be kind of neat. You can, yeah, and some people can modify these dishes too for different bands. So you could actually turn it into a whole bunch of ham bands that you use it for and make this a transmit and receive dish as well, and happen to have it be a dual band antenna for your like repeater work if you're like doing mountaintop microwave contacts or something. So lots of fun stuff you can do. There's a lot online for that. Cool. Other questions? Love it.
Michael's got a question.
Would it, if you're still using it as a cable TV antenna, would it be able to both receive and transmit at the same time? Like if it was receiving a cable TV signal and you were transmitting through the radio at the same time, would those mess up each other or would those work independently?
Yeah, so it's kind of Ryan's question too. Like electrically, yes, it would work. Right now, there is an interference question of the hardware that's in there. So like the actual receive element here there's some amplification that happens in here and some biasing that happens. So if those electronics are impacted by the proximity to a higher power transmission, they might not be happy, right? It depends on how they design this. So you might need to like shield this more or put some grounded aluminum foil around it, or, you know, because these aren't always a metal box. They're sometimes just a plastic box because they're expecting to be on a rooftop away from everything. So you might have issues, right? I haven't tried it out personally to know if it does cause an issue. And I think it'd be very specific to the dish you got. Like some dishes will actually have multiple LNBs down here. So they'll have like 3 or 4 different receiver horns there that are able to listen to different satellites or different bands. So it's possible that one of those would have interference, or that there would be some interaction with either VHF or UHF, or maybe a specific frequency in there that happens to line up on some harmonic of one of the received frequencies that you're getting. So yeah, I would say there's definitely a high probability of something happening there. You'd have to try it out, and it would be very situational, I think, very specific to the hardware that you're using, the bands you're at, and what happens, like a lot of other interference problems too. Good questions. I'm glad you guys are thinking about that, because that's exactly the stuff that's weird, right? You think about it like a big radio site that you have 3 different radios here. One of them is receiving, the LNB is only receiving, and the other 2 could be transmitting or receiving, right? And the frequencies and the combinations of the frequencies and how they interact with each other, that's all part of the game. So yeah, you could definitely get it to a point where you could do all 3 things at once. It just might not work out of the box, depending on, because you're relying on this, the LNB, whatever they designed this dish for, you're relying on that engineering, and that might not have considered high power VHF and UHF ham band transmitting right next to it when they did their design, right? So, and to keep in mind, they are typically, oh, what's my brain fart there? Yeah, typically they're designed for like part 15 FCC, like that they don't cause harmful interference, and that they can accept harmful interference, right? That they don't do anything weird if something transmits near them. That's like part of the FCC tests for most electronics gear. That's one of the things to consider here too. So, you know, but you are exceeding those levels probably by quite a bit if you run any amount of power. Now, if you're just running 5 watts through this, it'd be no different than just holding your HT next to a computer monitor, right? Some computer monitors, it'll cause it to reset. Some computer monitors, it'll fry. Some computer monitors won't even care. These monitors, if I transmit with a high gain VHF antenna here, it'll cause my monitors to go goofy. They'll still be there, but they get a little bit fuzzy, right? UHF is fine, even at high power. So it depends. And cool, Matthew dropped a link in the chat. Apparently Mark Smith built one too. I didn't realize that either. So, oh yeah, he did it a year later. Oh no, his is a slot HF antenna. So that one's a little bit different. And actually we can do a brief aside on that if you want, Matthew. So it's the same concept, right? But a totally different frequency band. And that was one of the antennas that John Portune also designed, I believe. So John does a lot of fun designs. If you visit his website, w6nbc.com, he's got links to all his funny talks and some fascinating antennas he's built. He gets into QST a lot. He publishes a lot of his articles. And there's some really fun antennas that he's built that like are stealth antennas or just made with wacky things or out of copper pipes or these weird square shaped ones for 6 meters and all sorts of fun stuff. So if you want some inspiration for fun antenna projects, I highly recommend chatting with him, or get him to come up and do a workshop at the club or go visit his house. I'm sure it's fun.
Cool.
Any other questions?
Any other questions for Marcel? CPARC should build a cube antenna. Cube antenna? No, that's what Marcel was talking about. Yeah, I saw on his website before. We designed it's like a copper cube for 6 meters.
Yeah, someone's gonna steal the copper though. That's the problem.
I mean, we have a pile of copper that we don't know what to do with.
There you go. Matthew, that answers your question for what to do with those old cables.
Yeah. Marcel, I have sort of another question that may just be silliness. So the dish receives, so the dish is sort of reflecting back stuff to be received by that little antenna on the end. Is there no way to like sort of reverse that to transmit? Like, did you have to make it into a slot antenna because that's the only way that would work? Or could you somehow use the dish to, it seems like it would be sort of unidirectional, but could that somehow work, or is that just silliness?
Yeah, absolutely. So that's actually, I kind of mentioned it earlier. I didn't really explain it though. So there are ham radio operators that use dishes for microwave contacts. So they'll, the main thing there is frequency difference. So if you wanted it to be a 2-meter directional dish, it would need to be much bigger. I don't know the exact math behind it, but your radius and your feed point and whatever else all make a difference there. So this particular dish is designed for gigahertz. I don't know exactly what bands this one was for. But if you replace this receive only horn with something that can receive and transmit it, you could absolutely use this as a transmitter that would be very directional to the left here, right? To the left and popping out of the screen. But yeah, that's definitely done. And if you look around at like microwave contesting, there are a bunch of hams that do that, especially up in like the Mount Diablo area. So at Pacificon, there are a bunch of folks that do that. Baycon had a talk from, I forget who it was. I think it was Doug, who did like 10 gigahertz contesting. So they have like a little chip and they mount the chip right here, and then it gets a nice amplification effectively because you're making it a directional antenna by putting it in the focal point of the dish. So yeah, definitely something you could do and play with. And that was kind of the comment too. You could turn this into a 3-band antenna by or more by adding different feed points to it.
Cool, thank you.
Yeah. Anyone else? Who's upgrading their license this weekend?
I should.
I was gonna say you still have not 48 hours, so 40 hours to study. So
Yeah.
get started.
Can I study for an extra in 40 hours?
Sure.
Yeah,
If
I
you're good at
tried-
memorizing.
I think I was one question away from passing last time I tried.
Yeah, try it. Andrew's printing out exams, so we'll be there.
Yeah, you can upgrade to general and extra this weekend.
Yeah, we'll have the exams there, just and your first attempt is free. So
Yes.
There we go.
that's the official for students. The first attempt is free. That's the updated policy. So
Was that because of hand cram last year?
I think so.
Poor Kevin.
Yeah, it really should be left up to the session managers. Okay, we should probably go off recording, but like it really should be left up to the session manager's discretion, in my opinion, because the retests are just frustrating depending on who's helping out, right? If you're doing online exams, it's 3 or 4 people that are spending another